Good day, class. We've been learning about quadrilaterals. Now, we're going to learn how to classify them by definition. But first, we need to review a few key concepts. First, let's go over opposite sides. Let's look at this polygon over here and what we mean by opposite sides. If I'm talking about the top of this polygon, what would be the opposite side? Exactly, the bottom. So again, if we're talking about the top, the opposite side would be the bottom. If we're talking about the bottom, the opposite side would be the top. Now, if we were talking about the right side of this polygon, what would be the opposite side? Good job, the left side. So if we're talking about the right, the opposite side would be the left. If we're talking about the left, the opposite side would be the right side. Second, let's go over the concept of parallel and non-parallel sides. If we look at this first polygon, and we're talking about the opposite sides, so we're talking about the top and bottom, we would notice that they are parallel. I drew a line that continued past the sides for the top and bottom. If you notice, these lines would never intersect or cross, so they're parallel. Again, parallel lines, if you draw them, never touch. They stay the same distance apart. Now let's look at the same figure, but let's look at the opposite sides for left and right. Are these sides parallel? Exactly, they're not. When we draw a line going past the sides, we see that they would eventually touch or intersect. So the left and right side of this polygon are going to be non-parallel sides. So if we were looking at this polygon only has one pair of parallel sides. Remember, pair would mean two. You have a pair of shoes. You have your left shoe and your right shoe. So this polygon only has one pair of parallel sides. Last, let's go over the concept of right angles. If we look at our polygon in this example, we'll notice that it does not have any right angles. Remember, right angles are 90-degree angles, and they make that perfect L shape. Do we see that perfect L shape on any of these angles? No. So this polygon has no right angles. Let's look at this one. Can we identify L shapes for this polygon? Exactly, we can. We would notice that there are four 90-degree angles. So we have an L here, perfect L here, perfect L here, and perfect L here. So this polygon forms four right angles. Now, let's use this information we just reviewed to classify quadrilaterals by definition. Now, in this example, we have this polygon. On the right side, we have key terms that we need to know and brief definitions. First, quadrilateral. Quadrilateral is going to have four sides. Does this polygon have four sides? Yes, it does. Let's go ahead and count. 1, 2, 3, and 4. So by definition, we could call this polygon a quadrilateral. Now let's go to the next term, trapezoid. The trapezoid only has one pair, or at least one pair, of parallel sides. Remember, parallel sides are opposite sides that do not touch, cross, or intersect. Does this have at least one pair of parallel sides? Good job, it does. If we notice, the top and bottom are parallel lines. These lines would never touch, intersect, or cross. So, by definition, we could call this polygon a trapezoid. Let's go to our next term, parallelogram. A parallelogram is going to have two pairs of parallel sides. So we already agreed that the top and bottom form one pair of parallel sides. Would the left and right form parallel sides? Yes. So we would have two pairs of parallel sides. So by definition, we could call this polygon a parallelogram. Now, let's look at our next definition or key term, rhombus. A rhombus is going to be a parallelogram that has four equal or congruent sides. Let's look at the sides. Are all of these sides equal? Are the top and bottom equal? Yes. But is the top equal to the left side? Even though we don't have any numbers here, we can see very clearly that the top is a lot longer than the left side. So by definition, I cannot call this polygon a rhombus. Let's go to the next key term, rectangle. A rectangle is going to be a parallelogram that also has four right angles. We've already agreed that this is a parallelogram. So what we have to do is determine, does this have four right angles? Does it have those four L shapes? Yes, it does. We look in this bottom left corner, this would be 1, then 2, 3, and 4. So by definition, we could call this polygon a rectangle. Let's look at our last key term, square. Square is going to be a parallelogram that has four equal sides and four right angles. Now, we've already agreed that this is a parallelogram, but does it have four equal sides? No, it does not. So by definition, we cannot call this polygon a square. Now, looking at our polygon, we've determined that this is a quadrilateral because it has four sides. It is also a trapezoid because it has at least one pair of parallel sides. By definition, we could also call it a parallelogram because it had two pairs of parallel sides. And last, we could call it a rectangle because it is a parallelogram with four right angles. Now, let's look at another example. So, we have our figure here. Can we call this figure a quadrilateral? Good job. Yes, we can, because it does have four sides. Can we call this figure a trapezoid? Yes, we can call this figure a trapezoid because it has one pair of parallel sides. If we look at the top and bottom, we will see that these lines would continue on, and they would never touch or intersect. Can we call this figure a parallelogram? Yes, we can call this figure a parallelogram because it has two pairs of parallel sides. We look at the top and bottom, they are parallel. And if we look at the right and left, you would notice that they're parallel as well. Even though these lines are slanted, if we were to continue the lines, they would never touch or intersect. So the left and right side are parallel sides. Can we call this figure a rhombus? Good job. We can call this figure a rhombus because this figure has four equal sides. If you were to measure the top and bottom, they would be equal. And if you measured the bottom and the left side, you would know that they were equal as well. So we can call this a rhombus. Can we call this figure a rectangle? Nope, we cannot call this figure a rectangle because it does not have 4 right angles. If you look here, this is not a right angle. This is not a right angle. Neither is this angle or this angle. So it has no right angles. So by definition, we cannot call it a rectangle. Can we call this figure a square? Excellent. We cannot call this figure a square because even though it is a parallelogram, it does have 4 equal sides. It does not have 4 right angles. And because it doesn't have 4 right angles, we cannot call this a square. Now that you know what to do, let's get to work.